Hello everyone and welcome to another video. In this one we are looking at Cambridge O-Level Winter 24 paper 1-2. Again, more recent papers so that you have an idea of what's going to come in your paper and how well prepared you are for it. Let's get right into it. Question number 1. The diagram shows a clothes peg. Which device is suitable for obtaining an accurate value for the height of the clothes peg? So this is like a really small distance. A tape or a meter rule is not suitable at all. A measuring cylinder measures volume. We need the height, which is a length. And for really small lengths, we use a micrometer. Which set of quantities all vectors? Acceleration vector, displacement vector, velocity vector. It's option A. Question 3. The diagram shows the motion of a cyclist during a ride that lasts for 14 seconds. What is the average speed of the cyclist for the ride? So for this, we will need to read off this value because this is a distance time graph. So that's going to give us the total distance, and then we can just divide by the time, which is 14 seconds. So this looks like 28 as the total distance, 14 is the total time. So 28 over 14 becomes 2 meters per second. Let's move on. Question number 4. The diagram shows the velocity, how the velocity of a train varies with time. Now this is a velocity time graph, which is technically speaking not in our syllabus. But if you think about it and if you have your basics down, then this is not going to be very difficult for you. Just like how the gradient of a velocity time graph was acceleration, similarly this gradient is also acceleration. The only thing which is now additional is just like how velocity can be negative, this graph can now also go below the x-axis. So we need sections of the graph where the magnitude of the velocity of the train is decreasing. So if I look at this one, this was some high positive velocity, it's going towards a low positive velocity. So the magnitude is decreasing. Let's say that the value here was like it's at 10 meters per second, and this is going towards 0. So we can see that the magnitude, the size, or the number associated with the velocity is decreasing. Now from here to here, let's say that this value is like -5. So here it's going from 0 to -5, and if I just talk about the number, ignoring the sign, then that's getting bigger. And if I talk about this, so here it's going from -5 to 0 again. So again, it's going again, ignoring the sign, it's going from 5 to 0, so the magnitude is again decreasing. So it's P and R, which is option B. Let's go on to the next one. A metal disc is squeezed in the jaws of a vice. Which property of the metal disc is unchanged when it is squeezed? The radius would change, distance between its atoms would also change, forces would also change as the atoms get closer together. However, the mass remains unchanged. Question number 6. Gravitational field strength in space is smaller than that on the Earth's surface. How are the mass and the weight of a satellite affected as the satellite moves away from the Earth and into space? So mass remains unchanged and the weight would decrease because small g is less. So that's option D. Question 7. A material has a density of 2.4 gram per centimeter cube. What is the density in kg per meter cube? Now I basically have this memorized that whatever is the density in kg per meter cube, you would multiply by 1000. But if you don't have this memorized, then you would just have to do this. So 2.4 for the gram into kg, I would divide by 1000. And for the centimeter cube to meter cube, I would multiply by 10 to the -6. Why is that? Because just 1 centimeter is 10 to the -2 meters. So to get the conversion between cm cube and meter cube, I would cube both sides, and 10 to the -2 cube because of indices becomes 10 to the -6. So I multiplied by this, and as you can see, when this goes up here, this becomes -3 minus -6, which is -3 plus 6. So in essence, it is 2.4 times 8,000, which is 2,400. Next, an object falls vertically through air. Which diagram represents the forces acting on the object? So force of air on the object should be upwards, not downwards. So not this, not this. And force from the earth on the object, which is the weight, that must be downwards, so not this either, and then it's option A. Question 9. A force F is applied to a lever at a distance L from the pivot as shown. The length D is the perpendicular distance between the force and the pivot. Which expression is the moment of the force? So it's the perpendicular distance between the force and the pivot multiplied by the force. So it's FD. The examiner was really kind about this because they've already also labeled this on the diagram. They've also said that it's a perpendicular distance. So it becomes really easy to figure out which distance to use. A rocket is launched vertically upwards by a constant force from its engine. Data for the launch is shown. So weight of the rocket, average air resistance, and the force from the engine. How much of the work done on the rocket is used to increase its speed in the first 100 meters? It helps if you draw a small diagram. Weight is downwards, air resistance is downwards, and the engine force is upwards. So you can see that the force from the engine is much more than these. So there's a resultant force upwards. And that is what is going to increase its speed. And I also have the distance given so I can find out the work done. So 3.5 minus 1.9 minus 0.1, which is 3.5 minus 2 is 1.5 mega Newton. Multiplying this by 100 meters becomes 150 megajoules. Which equation is used to calculate efficiency? So efficiency is output over input, useful energy output over total energy input. This is fine. Total energy input over output, wrong. If you have energy output, then the input also needs to be energy. So this is wrong, and it's definitely not the multiplication of the two. 4 objects of different masses are lifted through different distances and different amounts of time. In which combination of mass, distance, and time is the greatest power transferred? So if it's lifted like this, so I can say that basically all of these are being provided with potential energy. So mgh is the energy formula, and for the power I would just divide by the time. So mass is 2, small g is 9.8, the height is 2, and the time is 3 seconds. And then if I set it all out for all of these options, for this one it would be 1.5 times 9.8 times 2.5 is the distance divided by 2. Then 2 times 9.8 and 2 divided by 1.5, and then 1.5 times 9.8 times 2.5 divided by 1.5. And when you calculate all of this, you will see that the greatest power is in this case, which is also lifting a heavier mass, if you see, and it's also doing it in a lesser amount of time. So the correct answer for this one is D. 13. Air at a pressure of 1 into 10 to the 5 Newton per meter square, which is just another unit for pascals, is trapped in a container by a piston. A force is applied to move the piston down into the container. Temperature remains constant. Again, this is your hint that you have to use the inverse proportion between pressure and volume. Distance between the base of the container and the piston decreases from 0.18 to 0.15. So it moves a distance of 0.03. What is the new air pressure inside the container? So we'll use P1 V1 equals to P2 V2. So old pressure is 1 into 10 to the 5. Old volume was, I can say 0.18 times this cross-sectional area of the piston. So times 0.18A equals P2, the new pressure that I need to find, times V2. So now it would be here, and this distance would be 0.15. So now it's going to become 0.15 times A. A's cancel out. So 1 into 10 to the 5 into 0.18 divided by 0.15. So the answer for this one turns out to be 1.2 into 10 to the 5 pascals. A sealed gas syringe contains a gas that is kept at constant volume, which row describes how a change in the temperature of the gas affects its pressure. So constant volume, now it's going to talk about pressure and temperature. So if the temperature increases, pressure increases, and vice versa. So the answer for this one is C. 15. Melting temperature of gold is given. What is the melting temperature on the Kelvin scale? So you just have to add 273 to this. So that would be D, 1337. 16. The table shows melting and boiling temperature of three elements, argon, nitrogen, and oxygen. At which temperature are three elements in the different states? Alright. So let me mark on one line. Okay, I'll have to make this line. Okay, let's just make this here. So let's say this is that line. On this line, let me mark for the different objects their melting and boiling points. So the least temperature that we have is minus 218. So at minus 218, oxygen melts into a liquid, and then at minus 183 it boils. Now let's talk about nitrogen. So nitrogen is minus 210 is when it, let me use a different color, minus 210 is when it melts, and minus 196 is when it boils, so when it turns into a gas. And then minus 189, so minus 189 would be here. Minus 189 is where argon melts, and minus 185, these are very, very close, is where it, what do you call it, is where it turns into a gas. So at minus 220, which is here, nobody has reached their melting temperatures yet, so they are all solid, so they are all in the same state. At minus 205, which is somewhere here, this has melted, so they both are in liquid state, so they are not all in the different states. At negative 190, so 190 would be here, right? So this has already become a gas, this is still a solid, and this has turned into a liquid, so this is the correct answer here. At negative 175, all of these have turned into gases. So that's why the answer for this one is C. The diagram shows a liquid at room temperature in a beaker. What reduces the rate of loss of liquid by evaporation? So putting a lid on the beaker, right? All of the others actually cause the rate of evaporation to go up. 18. What is the color and what is the texture of the best absorber of infrared? So best absorber must be dull black, which is B. Next. Which row gives velocity and wavelength of a wave that is an ultrasound wave? So velocity and wavelength. So velocity of a wave, if that's 330. So it's talking about ultrasound, right? So we know ultrasound is frequency greater than 20,000 hertz. So in all of the cases, I would need to use the V equals to F lambda equation and find out the frequency, which would be V over lambda. So in option A, that would be 330 over 6.6 centimeters. So that becomes 0.066. This turns out to be, this is 500 hertz, so definitely not ultrasound. The next one, that would be 890 over 89, which is 0.89. So this is going to be, I guess, like 100, 1,000. 1,000, this is also not ultrasound. 1,500 over 6 centimeters, so 0.06. This seems like this would cut it, maybe. Let's see. This is 25,000. So yeah, this is the one. And in the last one as well, you would, I'd expect that you would not have a frequency greater than 20,000 hertz. The diagram shows a ray of light incident on a plane mirror. What is the angle of a reflection? So angles of reflection or incidence are always marked with the normal. So if this is 30, then this is 90 minus 30, which is 60. So if the angle of incidence is 60, then the angle of reflection would also be 60. 21, an object O is placed in front of a plane mirror, which diagram shows the image I formed. So it's supposed to be upright, so it can't be this or this, and this distances are supposed to be equal, so it can't be this either, and it's A. 22, the diagram shows a ray of light traveling from air to medium. What is the critical angle for the boundary between medium Q and air? This is not really a difficult question, but it's definitely more involved. Again, you will have to use the same idea that angles are supposed to be with the normal, which is the dotted line in this case as well. So 90 minus 42, this is 48, and 90 minus 49.5, this is 40.5. Using this, I can now calculate the refractive index, which is going to be sine of the bigger angle over sine of the smaller angle. So sine 48 over sine 40.5. Let's see what this turns out to be. So I don't have my calculator with me. So sine 48 is 0.7431. Sine 40.5, that's 0.6494. So let's see what this turns out to be. 0.7431 divided by 0.6494. That's 1.14. And now I have to find the critical angle. So that would be n equals 1 over sine c. So the critical angle would then be the sine inverse of 1 over n. So sine inverse of 1 over this thing. And let's see what that is. So 1 divided by 1.14, and then sine inverse of this, which should turn out to be option C. Let's move on. Which two waves are components of the EM spec? That's not light and sound, not this and this, not this and this, X-rays and microwaves. The diagram shows an iron nail in 4 different situations. In which diagram is the nail an induced magnet? So if a nail is, an iron nail is brought close to a magnet, then it would get magnetism induced in it. As long as these switches are open, so it's not going to be magnetized, because since there's no current in the coil, there's no field of the coil, so that can't induce magnetism in it. So the answer to 24 is A. 25, which row correctly shows a magnetic and a non-magnetic material? Aluminium is not magnetic, not magnetic. Iron is a magnetic, steel is a magnetic material, and iron is not non-magnetic, it is magnetic, so it's C. A lot of people do make this mistake, which is why the examiner keeps on giving this question again, which is that copper is not a magnetic material. Yes, it is an electrical conductor, but it's not a magnetic material. A freely suspended magnet is held perpendicular to a uniform field as shown. Magnet is viewed from above. What happens to the magnet when it is released? So the field lines show the direction of force on the north pole, so it moves like this, and on the south it's going to be in the opposite direction, so it rotates like this, and it would stop rotating until this becomes vertical. So when it becomes in this orientation, now it would not rotate anymore, because the field on the force on the north pole is like this, the force on the south pole is like this, so there wouldn't be any overall moment, because if this is how it's pivoted, so it won't be able to rotate anymore. So it turns through what do you call it, a 90 degrees anti-clockwise, and then it stops moving. Oh no, but yeah, so it stops moving, because in this case there is no resultant force on it. The resultant forces cancel out, right? If there was a resultant force, then it would have moved, but no, it would not move here. So that's B. 27, a plastic rod becomes charged when it is rubbed with a cloth. Which statement gives the reason for the charge on the rod? So that's because the one of them loses protons, the other one gains electrons. The plastic loses protons, not true, not true. Plastic loses electrons, so if it loses electrons, it cannot become negatively charged. It must be D, which is true, that it loses electrons and becomes positively charged. 4 resistors, each of resistance R, are connected in series with a cell of EMF E. From left to right, what is the current in each of the resistors? Because they're all connected in series, the current in all of them would be the same, so it can't be this, can't be this. Total resistance would be 4R, so the current would be E over 4R. And I've just used this, that V equals to IR, so I equals to V over R. So it's going to be option A. 29, how can 1 volt also be expressed? So volts is work done per unit charge. So you can say joules per coulomb. That's this. 30, X is a piece of wire with length L, area A, resistance R. Wire Y is made from the same material and is connected to wire X to produce a component with a total resistance of R by 2. What are the dimensions of Y and how is it connected? Okay, so it's made from the same material, it's connected to wire X to produce a total resistance of R by 2. So if it is connected to provide a total resistance of R by 2, then it needs to have the same resistance if they were in parallel. First of all, let's just understand this, that if I want the total resistance to be R by 2, I cannot connect another resistor in series to this, because that would just add this resistance and there's no way that this would go down to R by 2. So it has to be in parallel. And also I know that for the resistance to halve, and if I want the resistance to halve, the other resistor must also have resistance R. And I also know that resistance is proportional to length over area. So both of these effects must effectively counter each other. So let's say if I'm talking about option A. So if length doubles, then area would have also doubled, so that overall there's no effect. But in this case, if length doubles and area becomes 1/4, then resistance would become a factor of 4. And this would actually cause the resistance to go 8 times up its value, which is not what we need. However, C is exactly what we need, because here the resistance goes up by a factor of 4 due to the length, and because the area becomes 4 times as well, so this causes the resistance to become 4 times its value, this causes it to become 1/4 of its value, so overall there is no effect. And C is the correct answer. This was definitely a more technical question. 31. Which circuit contains a fuse and a diode? This is the diode. None of these are the fuse. This is a fuse. This is a lamp. This is a fuse and this is a diode, so it's option D. Easy. 32. How is energy transferred within a kettle that is powered by the mains supply? So in that case, you have electrical energy which is transferred to thermal energy. So electrical work done to thermal energy, which is option B. 33. A magnet moves through a coil of wire as shown. So this is moving in. Magnetic poles are produced at the two ends of the coil as the magnet enters and as the magnet leaves. Which pole is induced at P when the magnet enters? So when it enters, by Lenz's law, this would oppose this inward motion. So this must also be north. So this is north, north. And when Q leaves, so when the magnet is at this position, the magnet would attract this south pole to prevent it from leaving. So this would also be north. So it's both north. 34. A straight vertical wire carries a current in the direction shown. What is the pattern of the magnetic field around the wire seen by an observer viewing the position from above? So if you're looking at this from above, what you will see is that the fingers are curling in a clockwise direction. Right, let me just get this straight. So yeah, that's going to be a clockwise direction throughout. A is wrong because it has like these contrasting directions. B seems almost right if you think about it. Okay, so first of all, B is not even clockwise. So yeah, it's not right. And then it's between C and D. So with C and D, I can see that the one which is clockwise is this one, which must be correct. And additionally, it also shows the increasing spacing, which is important to show that the magnetic field strength decreases away from the wire. So that's why it's D. 35. Which part of a simple DC motor reverses the direction of current in the coil once every half rotation? That's called the split ring commutator. 36. Which statement about the nuclide notation is correct? R is the nucleon number, which is different for different isotopes. This is true because they will all have different number of neutrons. During a radioactivity experiment, the background reading is 28 counts per minute. A radioactive source is placed 2 centimeters in front of a detector, which is connected to a counter. Counter readings are taken with and without sheets of different materials placed between the source and the detector. So no sheet, you have this. Thin card, you have this 750. So there's no drop here. Now the thin card is basically used to block alpha, so there's no alpha here. So it's not alpha. But with the aluminium, the reading does drop, so that means it is beta. Right? So this drop tells us there is beta, but there is radiation which is still going through, which means that there is gamma as well. So it's beta and gamma, which is supposed to be option D. Let's go on. A radioactive isotope is injected into a patient as a part of a medical test. The radiation emitted is detected outside the body. What are suitable properties? So for it to be detected outside, it needs to have a high penetrating power, so that must be gamma, and the half-life must be of only a few hours, so that it's not excessively exposing the patient to radiation. 39. A student writes 4 statements about the solar system. Light takes approximately 3 into 10 to the 8 seconds to travel from the sun to the earth. Not true. It just takes 500 seconds. So 1 is wrong. So it definitely cannot be this. Earth approximately takes 24 hours to rotate on its axis once. So 2 is correct. So it cannot be this either. The moon takes approximately 1 month to orbit the earth. 3 is correct. So it comes down to 4. The sun takes 365 days to orbit the earth. The order is messed up. The earth takes 365 days to orbit the sun. So it's 2 and 3, which is option C. What is never formed by the explosion of a red supergiant? So we know that this leads to a supernova. That's what the explosion is called. And later it can lead to a neutron star and a black hole. And with the supernova, you also have heavier elements forming. So all of these are possible. But the white dwarf is something associated with only low mass stars which form a red giant and not a red supergiant. So that's C. So this was another paper. It's worth doing. It also has like a few tricky parts in it. So yeah. So that's this video. Like this video, comment if you have some suggestions or improvements. Share this with your friends who have been struggling with recent yearly papers, and subscribe to the channel because soon before the exam I'll also be doing a paper prediction for MCQs. So stay tuned and keep watching.